So, all right. So I'll go ahead and get started. First off, interesting fact: you can, when we create these courses, I found out last semester you can actually put animated GIFs as your class icon, which so of course I went and took full advantage of that. So let me tell you a bit of a story. You may have probably signed up for this class pretty late, right? When did this class appear?
The first day. Yeah. Priority registration.
First day priority. Yeah, we noticed so we had noticed that we had a bit of a wait list, and when I say we, I mean I had no part of this actually. It was the vice chair. He had noticed that there was that we had a ton of students who were trying to get into this course, and he went ahead and registered this course without telling me. So this may sound like I'm complaining. After all, I do have 8 sections to teach this semester, and you guys are, and this course is just one of them. The other is 6 of Python, and another is a graduate version of the course, which is actually important. I'll get into that. So it may sound like I'm complaining, but honestly, I'm actually thrilled because it's my favorite class to teach by far, so I'm very happy to be here. Data structures is by far my favorite class because we get to have a lot of fun of it in that. And the important thing, and so the most important thing to tell you guys right now from the start is that this is not a traditional lecture. We are going to be doing what is called a flipped lecture in this classroom. So there was no warning about this. That's okay. But the idea here is for it to be less work for this class, not more work. Because the main thing when that happens, so how many of you had a programming assignment that was you thought it was going to take an hour and it took 10 or 12, right? Yeah, totally. And if you had gotten an immediate response from your teacher, do you think it may have been taken 2 or 3? Or you had some help? Yeah. So that's the philosophy behind this class. Rather than having you bang your head against the wall for something that you accidentally did for 3 hours, 3 hours ago, and you cannot figure out for the life of you what it was, and then it turned out basically you were calling the wrong function somewhere, or you were reading int I is equal to int j is equal to 0, except and then the for loop was int j equals 0, j is less than something dot length, j plus plus, and you were reading that, but instead you had to actually put I plus plus, done that a million times, right? And so the entire point of this is that I am going to be available to help you to basically fix these mistakes. So a flipped classroom, the way that works is that I have pre-recorded all the lectures, and I've actually done a good job of making sure that these lectures are much more high quality. Something that you get a benefit of us having done a graduate course of this. So over here on Pages, on your Canvas course, you will find various playlists for each of the lectures. So by the way, the first video is a lie. It gives you way too much of a expectation of what the video actually looks like. We started a master's in IS&T program back last fall, or rather, it was back last spring. We did a pilot course of this. I think it officially launched this fall, but I was working on it basically since last year. And what part of that was is that basically we had to figure out what creating some high quality video lectures for that. And it turns out all of our budget for that went into these high-end module videos at the very beginning. And so if we click on the playlist that I have set up, you'll see that if it loads up, that basically the first video is going to be an overview video, and then the rest are screen captures. The first week is meh because I haven't been able to replace those, but the second week is stuff that I actually re-recorded about 6 weeks ago. And you'll see that they're basically, I managed to actually get set up with a green screen and stuff, and managed to do a lot of, so anyway, it's a much more pleasant experience. This is you guys benefiting from basically a course that you've never even heard of, which is the Data Structures and Object course that we've designed for our online class. So anyway, so now that I've told you what a flipped lecture is, again, let me go back to this. So I'm trying to post these basically as make a playlist for each week that we're going to do, because one of my issues was I gave you guys the last couple times I taught this, I just threw an entire 160 video playlist at all the students and told them watch up to this, point in, for each week. And instead, I'm just simply creating a playlist, right? As you can see, this is 7 videos. The videos themselves, I try to make them basically at most 20 minutes. Most of them range for 10 to 15 minutes. Some of them range for like this one over here, I think is like 5 minutes. This one might be like, one of these is 3 minutes, one of these is 5 minutes, not particularly long, right? Some of them are longer than others, but basically you're looking about 2 hours of videos a week. Yes. Sorry. 2 hours of video a week, okay? Which is about the equivalent time you'd be spending in class, listening to me drone on and then losing your focus and then trying to regain your focus and wondering what the heck was I talking about, and now you're completely lost. And instead what we do is that we turn these lecture sections into additional lab time, essentially time for you to come in and work on your homework. As well as time for basically I'll try to do once a week maybe a short quiz. Quizzes will be done on Canvas, so you can do them on your smartphone or on your computer. They'll basically be auto grading, so you'll be able to see what you get on those. But for the most part, it will be time to work here, to consult with your peers, to consult with your peers. I encourage people working together, especially like you'll see for this first one, because not everybody has like a laptop they can reliably use. But I can guarantee that like 3/4 of the class, half to 3/4 of the class does have a reliable laptop that they can use, and so pairing up is good. So that brings me to the, I guess that should bring me to the syllabus over here, which you can find under this conveniently labeled syllabus tab. For the first week, you'll want to watch the object-oriented programming videos, but and the second week we'll be doing array lists. But here's basically all the topics we'll cover for this course. This week is just going to be like review, because people are going to be might move to a different section. People will be trying to get into this section. You understand how the first week can be crazy, right? People might be coming back from vacation very late. That kind of stuff happens. So I do try to do review. Plus, you may have not programmed all summer, right? So definitely we're going to just do this week as review. Here's all the topics. We'll get into this kind of stuff, starting with array list next week. You found the place and the time. I'm not really sure why I have to put this in the syllabus. And then your labs are at the ungodly hour of 9 o'clock on Friday, I think. So, I hope I changed that from this semester. Anyway, I'm going to hope to speak to our RTA so that he can also be present during these times, so he'll help you. So he'll be here for the lab and the lectures. Sheng has been my TA before. I just got to copy down his information, and he's really good. I like him. So, make sure you have a C better in math concepts and 1068. If you just squeaked by with a C, you might be in trouble for this class. If, on the other hand, that basically you just missed out on a B, then you're probably okay, right? So, God knows I've just missed out on a B before, and my record is not as an undergraduate not necessarily the most exemplary, having withdrawn a class almost every semester and that kind of stuff. Graduate class I did very well. So, but by then I had finally learned how to study and also developed a work ethic, which was non-existent during my freshman year. So, attendance, I do expect you to be here because we'll be giving quizzes out in the labs and lectures. They're going to be short. They're basically very, very little impact on your grade. They're a combination of participation as well as actual quiz. We'll do it, and you'll see that there will be freebie questions that just are there to basically say, I took the quiz. If you're sick, don't come to class. If there's an exam that day, don't come if you're sick, right? Because if you're sick, you're not going to perform optimally on the exam. If you're sick, you're going to infect other people. Stay home. Just let me know, and we'll arrange for you to make up whatever you need. Right? I want you guys to be well. I don't want you to stress out. I don't want you to get other kids sick. Well, not kids. You're all adults, but anyway. So academic honesty. So don't cheat. I guess is what I'm saying. Don't blindly copy stuff on the internet. If you happen to find something that you need from the internet, like looking up, oh, there's an add all method, and this is how I can do this. Or, oh, I found this really interesting loop, and I really want to use it. Then cite it. Okay? Cite it, use your comments to cite, but don't, right? Worst that can happen to that point is I tell you you have to do it yourself. But once you cite it, it's not plagiarism, right? So if you need to speak to DRS, speak to DRS. If you need accommodations, extra time, let me know. Also recordings, these kind of sessions that I do where I do a review, I'll record them and upload them onto YouTube. All right, breakdown for grading, which is what everybody wants to know. Finals, I think going to be a quarter. I actually got asked that. It's going to be a quarter or 30%. But about 65% of the grade is going to be exam-based, which is, we're just an exam-heavy course. It's just always the way it is. Mainly because we like to make sure that you guys understand the stuff with the exams. Yeah, it's high pressure, but you'll do fine on them. If you understand it, generally you get a B or higher. We find that in my classes, there's a very bimodal distribution, which means that basically you get one bell curve that's clustered around 80, 90, and then another bell curve that's clustered around 60, 70. So there's extra credit opportunities available on the exams and the assignments. I don't give extra assignments or tests to make up specifically for you, but there will be an extra credit assignment, a couple extra credit assignments throughout the semester, including one in the second week because that's when you're the least busy. So might as well give you some time to do. I will usually drop a lab. So you get a freebie. You can say, I don't like this. I'm going to do something else, or I'm too busy this week. I've got exams, right? I will use plus-minus grading, but I generally just do that for your advantage. So basically, what I'll do, last semester, what I did is the way I curve is generally I look for gaps for cutoff points. And there's not too much of a difference between 90, a 91 and a 90 and a 90.7 and a 90.2 and then an 89.7. Right, but generally what will happen is I'll give the 89.7 and similar grades like that an A- once we're below the 90 range. And then after that, I will, so the cutoff last time I taught this class was I think an 80, it was an 88 for a A-. And then similar for a B, it was a 78 for a B. So generally, you need above a 70 to pass the class. Some exceptions will be made, but doing all your assignments and quizzes will basically help you create a buffer in case you're worried. But generally, what we see is that we get the majority of the class gets A's and B's, and this is true basically throughout the entirety of computer science, a third of the class will have a D, an F, or a W, which means that, and most of them will have withdrawn rather than getting a D or an F. The people who get Fs are the people who just never show up, never do any work. If you make it to the end of the course and you've been struggling the entire time and doing terribly, but at least you've been there making an effort, but you just don't understand the stuff, you're getting a D. You're not getting an F. I don't like giving out Fs because D means you can't go on. It's not going to kill your financial aid or anything. And I've had arguments with the financial aid office after I give an F. They try to rescind student aid or something like that because of their weird policies they have. So yeah. Okay. So yeah, I've already talked about quizzes. So let's just talk about the assignments and labs. They're the same thing, right? I give you an assignment each week. We're going to go over the first one right after this. And what you do is that you can do them with someone. This first one you can explicitly do with someone and turn in the same code. Other ones you can work with other people and turn in your own code. But to get credit, what you have to do is you turn it in. I have a very, very lenient late policy, by the way. Right? So you submit it online to Canvas. That's so we know when you turned it in, right? And then what you can do then is you demo it to me or the TA. If there's something wrong with it, you did this, but you didn't do it the way I specified, I need you to go and fix it, or, oh, you totally forgot one of these sub-problems, right? We can then give you credit for what you have and then tell you to go and fix it and fix the other portion and turn it in, right? But demoing is how you get credit. That involves basically coming up to me or the TA during this time, the lab, or my office hours, and explaining the pieces of your source code. I'll ask you questions. ask you to explain your code, and then you'll get credit for it. This is, honestly, it's because I'm lazy, and creating Java programs is a pain because everybody puts stuff in separate packages, and downloading it and then trying to import it into the proper folder is just a pain. And honestly, right, I would rather you explain it. This also helps against plagiarism because if you just copy something and you can't explain it, I'm just going to tell you to go away until you can explain it, right? Or until you actually do it yourself, right? It's also a good way for me to catch cheaters because I can actually look at, I do generally remember the way, like, oh, have I seen this before? And sometimes it's because I know, like, you have similar code to him because you were working together at the same table and exchanging information, which is perfectly fine. I like collaboration. But like, oh, this is weird. You're doing a graph, but it's a tree. What? Totally happened a couple semesters ago. I had a student. Anyway, try to get your demoing done within 2 weeks of actually turning it in. Your late policy is 5% per day. That's 5%, not 5 points. So first day, 1 day late is 95. Second day late is a 90.25. This means that, and then we cap the maximum penalty at half credit. So you can always turn in your work for half credit. Of course, if you have like a medical issue, right, or you can't make it for some reason, then of course, you know, you have some, like you got jury duty or something like that. Then of course, right, then of course the late penalty won't apply. This is just generally if you turn it in late without any real excuse. So, right, exams, they'll probably be given in the lab section. They might be given in here. I'll figure that out. But you can expect them around week 5 and week 10. In other words, basically whenever everybody else gives them. The final exam, I have to replace this, but everybody takes the same final exam, unless you're in the evening section, which you're not, and because I'm not teaching in the evening section. It has a reputation for being difficult. This is because there's a lot of material to cover, but also because it's like on the last day of exam, like the last or second to last day to exam, and you're already exhausted, and then you figure, oh, I'm okay for this class. Don't really need to study. Study for this class. Prioritize this one. The exam, it really helps. Please note that if you have more than 2 finals on the same day, university policy allows you to request a professor actually move one of their exams. You cannot take more than 2 final exams on the same day. You shouldn't. It's considered cruel and unusual even for a university. So anyway, so click this link. You might find out you actually have rights. So you know. Okay, so with that, let's go ahead and get started. So for this week, right, again, in Pages, you'll find the lectures. Here on this link, you'll find a lot of the code that I've done in previous semesters. And then over here is just like a 10-minute overview of data structures done by the Crash Course YouTube channel, which is actually an excellent overview of basically everything I'll teach in this course in 10 minutes. So not everything, but like 70% of it. It's kind of, and we kind of use that as an inspiration for a lot of our videos. So for this week, I want you to watch the object-oriented programming video. It might help you if you've forgotten how polymorphism, inheritance, and that kind of stuff works. That's what I'm going over in this video: how to make objects, how to do polymorphism, how to do inheritance, how you do encapsulation, right? That kind of stuff. And that's what the theme of this week is about. Next week, I go over what is the list data structure, which you probably will have had some exposure to last semester if you took Dr. Fiore or Professor Jupin. If you took those classes with them, then I think they've exposed you to that. But this is a bit more than exposure. The first half of the videos are on basically how we use array lists and how we use generics with array lists. The second half of the videos is how do we actually build and implement the array list, right? How does it actually work, right? So a lot of data structures we'll be building from scratch in this class. Okay, so what do we have for this first week? The first week is a project I've given as a final project for 1068 a couple times, and it's called Fox and Rabbit. Okay, so it sounds like it's a very silly thing. It's easiest to demonstrate what it is by downloading the code and just simply let's go ahead and extract it to the desktop just because that will be easiest, even though that will be a mess. Okay. So, okay, and then I give you, for every assignment, I give you a PDF, by the way, of the write-up. Now, I've stolen this assignment, borrowed this assignment, used it, adapted it from another professor who basically showed it off at a computer science conference. It's a review of 1068. It does have a GUI. You may have never messed with the GUI. That's okay. You don't need to know how the GUI works, the graphical user interface. It's a fairly straightforward thing, so let's go ahead and run the program now that it's on the desktop. So, okay, so let's go and open up Geany, open desktop, so Rabbit Hunt. So I normally use, I'm normally going to be using IntelliJ to do this stuff, but just for speed's sake, I'm doing this, and I think, what, F8 to compile? Yeah, it's compiling. There we go, compiling safely finished, and then run it. So, all right, so it'll appear empty if you're using a Unix system at first, but that's okay. So you'll notice there's some controls here. So what we do is that we will do run. So this is a very basic game. The object of the game is pretty straightforward, because that game ended pretty quickly. This red dot is the fox. His job in life is to eat. He would like to very much eat the rabbit. Guess which animal you're playing as? You're playing as the rabbit. So the rabbit's job is to not get eaten by the fox. The board is completely random each time. So notice that there's empty squares. There's these bushes which block both line of sight and movement. We'll explain line of sight in a bit. But as you can see, the rabbit actually has a strategy for moving around, and the fox has a strategy for moving around. The fox is basically what he does is that he goes back and forth until he can't move, until he sees the rabbit. Once he sees the rabbit, he will move to the rabbit's last known position. So the game will last for 100 turns. If the fox eats the rabbit, the fox wins that round. If the rabbit outruns the fox for 100 turns, the rabbit wins that round. Your grade is going to be based on the percentage of times that your rabbit will be able to escape out of 300. So let's go ahead and take a look at the strategies. So first off, the strategy for the rabbit is actually, you may notice, not that great. And this is because, as you'll see, the rabbit actually doesn't have one. What he does is that he just simply says, let me choose one of the squares around me randomly and try to move there. So if it looks like the rabbit's just moving at random, that's because that's exactly what the rabbit is doing. The fox, on the other hand, has a strategy that we'll see here. That's what that yellow is that's his line of sight. First thing he does is that he looks all around him, and then if he can see the rabbit, he'll head in the direction of the rabbit. If he can't see the rabbit, then he will basically, and notice he couldn't see the rabbit there because it was out of the line of sight. So the line of sight is very narrow. Here we go. Boom, sees a rabbit, so he's now going to move towards the rabbit's last known location, even though the rabbit's going to continue moving. Once he sees the rabbit again, he'll update what he's seen. If he can't see the rabbit, if the rabbit somehow evades, he'll go off in a different direction. And he'll just keep traveling in a single direction. He'll basically pace back and forth until he hits an obstacle, and then he'll pace in the other direction. And if he can't do that, he's just going to choose another direction and pace in that direction. You can actually see the fox's code, but it's code for a predator. Not too much use for you other than to see how some things work, like how do you look around, and that kind of stuff. So here's that code over there, right? Here's the code for the fox. Here's the code for the rabbit. Now this may seem like a huge thing with all these classes, but fortunately for you, you not only just have to work on one class, you only have to work on one function of one class. So, which is this function over here, int decide move. Let me go ahead, do not disturb. Int decide move, which simply, I want you to basically implement this to be slightly different, which simply says, right now I'm going to return a random direction. Model.min direction, model.max direction. So we just need a smarter rabbit that's going to live for more than 100 turns. Now, the best grades I typically see are basically around, once you get a working strategy done, it's easy to get into the 70th percentile, like 70% survival rate, and you can boost that up to like 92% survival rate. Your grade is out of 120, and it's the square root curve of your survival rate, plus 20 points for demoing. So what is the square root curve? Well, it's fairly straightforward. What we do is that we'll take your survival rate, say your rabbit survives 64% of the time, we'll take its square root and multiply by 10. So a 64% survival rate is an 80. An 81% survival rate is a 90. Make sense? Square root multiplied by 10, and then we add 20 to it. So we can see, so once you get basically a 64% survival rate, you're getting 100 out of 120 points on this. So most, and points, by the way, they're like inclusive to their own group. So 10 assignment points can only be like equivalent, can only be compared to other assignment points, right? As opposed to exam points, which are completely different. Which I should mention. Right, so I have recorded these lectures, but I do not believe I am like a perfect human being by all means who never makes mistakes. So I have a bug bounty in place. If you find a mistake in my videos that I don't like correct or something in my video, an uncorrected mistake in my videos, leave a comment on that on the channel, timestamp where that mistake is and explain where it is to claim it, and that will give you a bug bounty. A bug bounty is 1 exam point. So it's like, and you can get up to 5 of those. So up to 5 of those, in addition to whatever extra credit is on exam. So if you find a mistake, let me know about it. And if it's a mistake, I will give you an exam point. If it's not a mistake, well, just don't like tag every second of it, because that would really make me reconsider the policy of a bug bounty. All right, so going back to this. So let's take a look at our at this whole thing. So let me open up the animal class and the model class, which are the important ones. So this uses a common graphical user interface paradigm called the model view controller paradigm, where basically there's 3 elements to the GUI. The model, which basically is the logic behind everything that goes on in the graphics. So basically that's the underlying code, the underlying logic, but it doesn't actually handle any of the drawing or anything the user can see. The view is what the user sees. You're not going to have to mess with anything about that or know anything about that. That's what displays that graph to the user. That's what updates everybody's position on the board so we can see it, right? The game will still run without any of the those things. Like, take a look at the grader, by the way. Like here, I'll go ahead and compile the grader, right? The grader works without a thing, right? Here, the rabbit randomly escaped 3 times out of 300, or 1%. Square root of 1 is 1 times 10, so his grade was 10, right? So, but notice it didn't need any graphics to do that, right? It's just, view is just simply responsible, and the controller is fairly obvious. Those were the buttons, right? And those just simply let us know if we want to continue, how to handle this in the game. So a bunch of the other classes, fox, rabbit, animal, those are like all parts of the model. So the animal, we'll take a look at the model first. The model has all these private variables. So the field, which is obviously where they're playing, the number of rows, the number of column, a rabbit object, a fox object, right, and then the positions of each of those animals. There's also the bush object. All bushes are the same bush. They just simply it just simply occupies like multiple spaces at once somehow. But in terms of memory, that's way more efficient. And then the random number generator, right? Then a bunch of Booleans. And then also there's all these static variables here that are kind of important. So such as what direction you're in. So north is represented by 0, 1 is northeast, 2 is east, southeast is 3. But that's hard to remember, right? Remembering which number goes to which direction. So instead, say I just want my rabbit to run north all the time, all I would have to do is model.n to have it run north all the time, right? Because, or I could do return 0, but I could just do model.n instead. There's also a 9th direction, which is 8, which just represents stay still, which is actually very useful, right? So there's all these static methods over here that are kind of useful, but a rabbit, let's go ahead and see. Let's now look at the rabbit. So the rabbit is an animal. So we're going to get all the stuff from animals. Super, who here hasn't seen super before? The super keyword. Anyone? Well, in case you've forgotten what it is, super, what that means is I just call my parent's constructor. I'm lazy, I'm not going to build my own constructor, so I'm simply going to use my parent constructor to do that. So let's take a look at animal. So an animal has a reference to the model. It's private though, so the rabbit can't use it. I should emphasize, basically, when I said that you only have one class to worry about, it's also the only class you can worry about. It's the rabbit is the only code you're allowed to change. Okay? You can add all you want. You can add more than one method. You can add helper methods. You can add helper variables. You just can't have more than, you just can't have any other class that you modify but rabbit. Okay? So animal just simply sets up its position. A random obviously just chooses a random in a range. So there's a couple of very useful methods that animals can do. The first is look, which given a direction will return an int. Finds the first thing visible starting from this animal's current position. So if I look north, I'm going to get a number back. So if I decide to look in a direction, I'll get a number back. What is the number? Well, that's according to model. Model has also numbers to represent all the things you can look at. The edge of the field, a fox, a rabbit, or a bush. But remembering that 0, 1, 2, or 3, again, hard, so you just simply use model.edge, model.fox, model.rabbit, or model.bush. So for instance, maybe if what I'll do is maybe write a basic if statement, which is if look dot model n, sorry, if look model dot n equals model dot edge not necessarily a great survival strategy, but I'm just trying to show how this is showcase how this is going to work. If I look to the north, and that is equal to the model edge. You'll notice this with my fonts, by the way. I use fonts that enable ligatures, which I can, so the single equals starts looking like 2 equals, right? What about not equals? How does that look, right? So not equals, that's easy to read. So it's really, again, if you copy and paste it and put it somewhere else, it's going to look like a not and equals. This is just simply the font choosing to render 2 things together. It's like how if you have an F and an I, in some fonts, the F will kind of go over the I. This is just simply taking that but to an absurd level. Okay, so if the model is equal to the edge. So if we look, see the model's edge, then maybe I will return, I'll return model.north. So if the edge is at the end, I'll go that way. Otherwise, I'm going to go model.south. Again, this is not meant for any survival strategy whatsoever. Instead, I'm going to just simply, but we are going to go ahead and run this and see what happens anyway. Run. So here, right in this scenario, so we stop and run it. Sorry, stop and do a step now. Notice that the rabbit's actually looking to the north now. Right, that it's going by too quickly for it to see. But now, okay, he's at the edge. So let's go ahead and see, aha. So now he's looking north and seeing a bush. So in this case, he's going to go down. Okay. But that's not, but making your decisions like that, the most important thing you're looking for, honestly, is the fox. So the first step is that I try to get to today is basically writing a pretty simple loop. Look all around you in every direction. Look at the fox to see how he looks around you in every direction. If I see the fox, run away from the fox. Okay? Now, running directly away from the fox will lead you into death eventually because you're going to bump into something, if that's your only thing. But getting to that point is not a bad point. Otherwise, if I don't see the fox, stay put, because I want to just show you something to help cut you off. Basically, a lot of people they try basically reverse engineering what the fox does. That's predator code. You're prey, which means you basically don't have to do any work if you think about it, because he has to find you. Going to find him is a bad idea. So let's go ahead and just simply do, instead of random, we're going to do model.stay. Okay, and see if that improves our survivability at all. So now, if I just simply stay put, right, well, I'll probably die a lot still, right? Okay, but now notice he's not doing anything. So let's go to greater. Okay. Run the greater. Slightly better. You escaped 5 times that time. 4 times. 6 times. So it seems to be doing a bit better. Just a smidge better by actually staying still. And this is because actually the fox has to do all the work of finding the rabbit, and the rabbit can end up in a good position to not run away. So once you get the rabbit running away from the fox, that's what you wanted. That's basically a good place to be in. The other thing you want to do is that once you've done that, think about how the line of sight works, right? Running away from the fox is pretty bad, but there's 2 things to note. First, line of sight rules, basically they're asymmetric, right? It's possible for you to see the fox without him seeing you, because you can do the look, and maybe if you move out, if you move out of the way first, right, then he won't be able to see you if you move correctly. That's why you saw when we were initially running this program, there were a couple times where it looked like the fox should have seen the rabbit and pounced on him, but the fox moved off in a random direction. That was because basically the rabbit moved out of the fox's line of. What happened is the fox moved into the rabbit's line of sight. The rabbit doesn't do anything because he doesn't know to, so he just simply randomly moves, and now the rabbit's out of the fox's line of sight, and so the fox just keeps going, right? So that happens asymmetrically. And the next thing to remember is that those are narrow. So basically, right, if the fox is looking in this direction, there's this, and this direction, there's this entire cone, which basically he can't see it. So taking advantage of that, and of those cones of basically no visibility, are very good ways to really boost your survival rate. You are allowed to use whatever strategy you deem fit. I say have fun with this. So that's all I have for you guys for right now, because I think it's about time to get started on this. So if you have any questions, please let me know. If you need help getting set up, let me know.